What is the difference between a prism and a pyramid? Whether you need good help, a genius writer, a brainy tutor, or a data analyst, Intuito4U has them all. It's like having a research dream team on demand. And if you are new here, then subscribe now for more amazing video just like that.
All right, let's dive into the world of 3D shapes for a geometric showdown. We're talking about two of the most famous families out there, prisms and pyramids. Now, they might look a little similar at first glance, but trust me, by the end of this, you'll be able to spot the difference from a mile away. So let's kick things off with a bit of a riddle. What on earth could connect the amazing structure of a beehive, a simple camping tent, and, one of the actual wonders of the ancient world? Well, the answer is hiding in plain sight, and it has everything to do with the shapes we're about to break down. Here's our game plan. First, we'll get straight to the key differences. Then we'll meet the family these shapes belong to, learn their basic anatomy, and then, the main event, put them head to head. After that, we'll go shape spotting in the real world and wrap it all up with why any of this actually matters. Okay, let's get right into it. The best way to think about prisms and pyramids is like two distinct but kind of related families of shapes. Our mission is to meet them and figure out what makes each one so special. First things first, we need to know the family name. Both prisms and pyramids are types of polyhedrons. Now, all that means is it's a 3D shape made up of flat faces and straight edges. The crucial thing here? No curves allowed. That's what separates them from things like a sphere or a cylinder. All right, now that we've got that foundation down, it's time for the formal introductions. So let's meet the two main characters of our story today. First up, the prism. Here's the deal with a prism. It is defined by having two identical ends. We call them bases. And these bases are perfectly parallel to each other. They're connected by side faces that are always rectangles or parallelograms. Just picture a classic cereal box. That's a rectangular prism right there. And then we have its counterpart, the pyramid. Now, unlike a prism, a pyramid has only one base. From that single base, you've got these triangular faces that all rise up to meet at a single point at the very top. And that pointy bit, that's called the apex. So to really compare these two properly, we need to be speaking the same language. And that means we got to understand their anatomy, the basic building blocks of any polyhedron. First up, we've got faces. Super simple. These are just the flat surfaces of the shape. A regular six-sided die, which is just a cube, is the perfect example. It's got 6 flat faces. Easy enough, right? Next are the edges. An edge is just that straight line where two faces come together. If we stick with our cube example, you can count them up. It has exactly 12 edges. And finally, vertices. A vertex is just a fancy word for a point, or a corner where all the edges meet. Our trusty cube has 8 of them. So there you have it. Faces, edges, and vertices. Those are our building blocks. Okay, we've met the family, we've learned the lingo. Now it is time for the main event. Let's put these two shapes side by side for a head-to-head showdown. All right, if you remember one thing, just one thing from all of this, make it this. A prism always has 2 identical bases. A pyramid always has 1. That's it. That's the fundamental difference. If you can lock that in, you will never get them mixed up again. This table just lays it all out so perfectly. You can see how that number of bases, 1 versus 2, changes everything else. A prism's rectangular sides create this uniform stackable shape, but a pyramid's triangular sides force it to taper up to that single point. But here's the part that always blows my mind. Look at the volume. A pyramid with the same base and height as a prism takes up exactly 1/3 of the space. It's just this really neat, elegant mathematical rule. And if you need a delicious way to remember all this, think about a Toblerone bar. The entire bar, that's a perfect triangular prism. It has 2 identical triangle bases. But what happens when you snap off a single piece? Boom, you've got yourself a pyramid. 1 triangular base and sides that meet at a point. It's both shapes in one awesome package. All right, let's take this knowledge out of the classroom and go on a little safari. It's time to spot these shapes in their natural habitat, the world all around us. Prisms are literally everywhere. They are the ultimate building blocks. You see them in the simple rectangular form of books and bricks, but they also come in other fun shapes, like the hexagonal prism of a pencil or the thousands of them that make up a honeycomb, which is one of nature's most brilliant designs. Pyramids are just as common once you start looking. You've got the huge, monumental ones like the square-based pyramids of Giza, all the way down to the humble, wet floor sign. And remember our camping tent? Well, here it is again. Depending on the design, it could be a prism or a pyramid. So, okay, this is all fun, but why does it actually matter? Well, it turns out these shapes are way more than just figures in a textbook. They are fundamental to how we build, design, and even see our world. I mean, think about it. These shapes are fundamental for a reason. Their structures give our buildings incredible strength and stability. The prism's shape is perfect for efficient packaging. Just look at any shipping box. And in science, we use optical prisms to bend and direct light in everything from cameras to binoculars. Even nature gets in on the action, using these shapes to form crystals and build honeycombs for maximum strength. So the next time you see a skyscraper, a cereal box, or even just a wet floor sign, you'll know exactly what you're looking at. The world is literally built on these simple, elegant shapes. So I'll leave you with a little challenge. What prisms and pyramids can you spot today?